Alright guys, welcome to Math 0106. This is lesson 2. We're picking up from the last video. So if you have not watched the last video, please go back and re-watch the last video so that you're up to speed with where we're at with the course. Okay, so last time we discussed what factors, factorization, prime, and composite numbers are. Now what we're going to talk about is we're actually going to work through these examples. So I asked you guys to work through these on your own. Notice that what I'm doing is I'm covering up what prime numbers are, so I don't know whether it's prime or not. So what I'd like to do is I'd like to say whether it's prime, composite, or neither. And then what I'd like to do is state why that's the case. And what are some little things that I can do to make sure that I don't run into problems down the road when I get an ugly number and I'm like, I'm not sure if it's prime or composite. Okay, so for number 1, I can automatically tell you that this is composite. And hopefully you know why. We said the only even prime is 2. So 8 is even, so it's going to be composite. In fact, anything that is even is going to be composite. So I'm just going to put number 3 as composite. I automatically know that. Now, for 13, there's no easy way of figuring out whether it's prime. What we can do is we can use our divisibility rules to see if they work on this. They're not going to. And once we've done that, then we're just going to kind of have to run through. 13 shows up pretty early in the list, so we know that that is going to be prime. Okay. The earlier ones you tend to end up memorizing just because you see them so frequently. Let's go on to number 4. 33. Okay, well, I know 33 is divisible by 3 because the rule for 3 is that if you add the digits, 3 plus 3 gives me 6 because 6 is divisible by 3, and this number is divisible by 3. So this number is composite. Also, anytime you have some repetition of digits, like 11, 22, 33, 44, 55, this is just saying, right, 1 times 11, 2 times 11, 3 times 11, 4 times 11, etc., etc. You know what, 5 times 11. A little tidbit about 11 that's pretty cool is that 11 has this symmetrical property. So one little cool thing for multiplying numbers that are larger, so let's say we want to do 11 times 11. Some of you guys have this memorized as 121. One little trick that you can do is whatever the number you're multiplying by, let's do another one. Let's do, say, 12 times 11. Okay, just to be clear here. So what you can do is use these two digits. They are placed in the front and the back respectively. So this one goes here and this one goes here. It's a little confusing because they're both 1. And then when you add these together, that's this number here. So to show you a better case is 12 times 11. So you put a 1 here and a 2 here because there's a 1 here and there's a 2 here. 1 plus 2 is 3. 12 times 11 is 132. And if you don't believe me, let's do it the traditional way. So how do we go about doing this? We go 2 times 1 is 2. Then we go 1 times 1 is 1. Put the 0 down. 1 times 2 is 2. 1 times 1 is 1. And when we add them together, we get 132. So nice little cool trick for multiplying by 11. Keep that in mind. It helps you to save some time. So the more you get exposed to math as we keep working through, if I come across a little trick that might make your life a little easier, then we shall do that. The last one, 89. What I would do, again, is run through the divisibility rules. So I want to maybe add 8 and 9 and see I get 17, which is not divisible by 3. I know automatically, right, from earlier, it's not going to be, it's not even, so I'm not even worrying about 2. It's not ending in a 5, so it's not divisible by 5. It's not divisible by 2 and 3, so it's not divisible by 6. And at that point, we've kind of exhausted all the options. It's not going to be divisible by 9. It's not going to be divisible by 10. So this becomes a little difficult, and honestly, you just kind of have to kind of chip away at it. I won't put something like this on the test. The only time that it would show up on a test is if it's something through HCC. I don't have any say in that. But we can see on the list that 89 is part of the list. So telling whether it's prime or composite really boils down to the project of just trying to chip away with the rules that we established in the previous video. And if it doesn't work, then you're just going to kind of have to guess and check till you get all the way there. One last question that I have here before we move on is, it's not one of the answer choices to the question, but what is neither? What number would be neither? And that number is 1, right? 1 is neither prime nor composite, right? Obviously, we can also say like negative numbers and fractions and things like that, but 1 is the one that sometimes people think they want to put as prime, but it's prime nor composite. So keep that in mind. Awesome. Okay, so let's see here. Let's move on. So the next bit is going to be talking about prime factorization. So prime factorization, in a nutshell, is, well, let's just go through this real fast. So this is each composite number has a unique prime factorization. This is true. What was cool about prime factorization, the reason why we like it, is it's unique. It's only one number has it. So sometimes people call it the DNA of a number, as it's a unique coding for every number. The prime factorization of a number is the product of the factors where each factor is a prime number. So they give you an example. They say 84. Well, 84 breaks down to 2 and 42. And then they break 42 down to 2 and 21, etc., etc. And then they do another example with a factor tree. So here we have the factor tree. Okay. So the factor tree is what I would do. I think it's a lot easier. So let's run through these. Let's do 8300 together. So let's start with 84. So we want to break these down to prime numbers. Now, I'm going to give you a suggestion. The suggestion is not what you have to do, but I would recommend it. Okay. So when I see this, I'm going to write two numbers. What I'm going to try to do is I'm going to try to put the prime number here, so that what happens is I have like a list, kind of like so, of just prime values all the way down. I think it helps you to keep things organized. So that's how I'm going to do it. You don't have to. You can literally just put numbers down and then work your way down. But this keeps things organized. It can get very confusing very quickly. The other thing that I'm going to tell you is that don't overthink it. Like, I see 84. There's a part of me that's like, hey, both those numbers are divisible by 4, so I want to do 4. Then there's another part of me that's like, hey, 8 plus 4 is 12. 12 is divisible by 3. Maybe I want to start with 3. It doesn't matter what you start with. So the easiest one is obviously 2, because it is even. It ends in a 0, 2, 4, 6, or 8. So because it ends in that, we can use 2. Notice that I'm still using the divisibility rules, and that's going to be 42. Why? Because 8 divided by 2 is 4, and 4 divided by 2 is 2. I'm not doing anything fancy here. Okay? So if with 42, again, some of you may be inclined to say 6 and 7. I'm like, it's even. Let me just do 2 again. So this breaks down to 21. Again, that's easy, because 4 divided by 2 is 2. 2 divided by 2 is 1. 21 we know is 3 and 7. If you don't know, that means, hey, you need to practice your multiplication tables. So this breaks down to 2 times 2 times 3 times 7. Now, the other bit that I want to talk about is 2 times 2. Another way of writing that is 2 squared. So we can say 2 squared times 3 times 7. So however many repetitions you have, that becomes the exponent. So if I had like another 2 here, then that would have been 2 cubed. If I had another 2 on top of that, it would have been 2 to the 4th. So not to confuse, there's only 2, so it's 2 squared. And this is the prime factorization. There's no other number that has this combination besides 84. So the other example they gave is 300. So let's do 300. Again, I'm not going to overthink it. I'm actually going to start with 3, because I think 3 and 100 is easier than 2 and 150. But if you thought 2 and 150, that's fine. I'm going to go 2 and 50 now, and then 2 and 25. I know it's even, so I keep breaking it down, and then I know it's 5 and 5. Now, maybe you thought differently. Maybe you saw 100 and you thought, hey, I think 5. And you're fine. It will work out no matter how you do it. In fact, let's do another combination. Let's say I did want to start with 2. It's like, hey, $3 divided in half, it's $1.50. Okay, so then I see 150, and I'm like, hey, that's divisible by 2. So easy way of doing this is 100 divided by 2 is 50. 50 divided by 2 is 25, so 50 and 25 is 75. So again, what I'm saying here is if you cut the number up into 2 different numbers, and you divide each of them by 2, and then add those pieces together, you can get the number. And you get comfortable with this, you really don't need a calculator ever to do division. Just cut numbers up into smaller numbers and add them together. 75. When you're working through these examples, a lot of times people will see something like 75, they're like, I don't know. 75 is a big number. Relate it back to the real world. So we all have played with quarters. 3 quarters is 75 cents. 25 is 5 and 5. So this, again, is the same thing. Notice that these combinations, you have 2 2s, 1 3, and 2 5s. Oh, I'm sorry. It's the same combination as here. I never wrote this out. This is 2 squared times 3 times 5 squared. So notice you had 2 2s, 2 5s, and then 1 3. So that's there. And notice that here we still have 2 2s, 2 5s, and 1 3. So 2 2s, 2 5s, and 1 3. So it still works. So the order doesn't matter. How you break it down is how you break it down. And your work may not match up to mine exactly, and that's perfectly fine, as long as the final result does. Okay, so that's how prime factorization works. So the nit and gritty part, what I'd like you guys to do now, if you haven't done so already, pause the video, work through these questions, and see how much your work compares to mine. So I'm going to assume that you've done so. Make sure you read the instructions carefully, right? The first question is saying list all the factors of 25. So remember when we said factors, and this is the part that's very important, what are factors? So we start with 1. 1 times what is 25? Well, 1 times 25. Does 2 work? No. Does 3 work? No. Does 4 work? No. The next one would be 5, and I can stop because 5 times 5 is, the next one would be 5, so that's my stopping point. So it's just 1 and 25 and 5 and 5. So the factors are 1, 5, and 25. Cool. So what are the factors of 49? Well, just again, it's 1 and 49. And then you're going to run through. Now, for the interest of space, I don't have a lot of space here. I'm not going to list all of them. But 2 won't work, and then I'd ask you to tell me why, and hopefully you're saying, hey, Anderson, it doesn't end in a 0, 2, 4, 6, or 8. Does 3 work? 4 plus 9 is 13. No, 13 is not divisible by 3. Does 4 work? No, there's no easy way of doing that other than thinking, 48 is divisible by 4, so 49 can't be. What about 5? No, it doesn't end in a 0 or 5. What about 6? Well, we said 2 and 3 don't work, so 6 can't work. What about 7? So I recall that 7 times 7 is 49. There you go. Now the next 2 are pretty cool. I like the next 2 because they are prime. So because they are prime, it's just 1 and 7 and 1 and 13. We spent so much time on 2, 3 and 4 have to be easy to compensate, okay? We actually did 5 earlier, and I'd encourage you to look at do I have it here? No, I don't. Let's just do it again. So this was the example, the original example, but let's do it again. So we can do 1 and 24, we can do 2 and 12, 3 and 8, 4 and 6. 5 won't work, so then we're back at 6. So there's your list. By the way, I'm writing the factorization, right? But if you wanted to write the factors, you would just list it. You'd go 1, 2, 3, 4, 6, 8, 10, 12, and 24. I'm not doing that because I don't have a lot of space here. So when you write one with the iPad, it's not a lot of space. Yes, I am doing this on an iPad. Okay, so let's go on to 48. This breaks down to 1 times 48, 2 times 24. We actually did this one, by the way, on another video, so hopefully you recall that and you were able, if you were following through, you were able to redo this on your own. 4 and 12. 5 obviously won't work. 6 and 8. 7 won't work, and then we're done. Okay. This one's going to be interesting. I'm actually going to try to scoot and give myself some little more space. 168. So we're going to do 1 and 168. 2, and so this is actually really easy to do in your head. 16 divided by 2 is 8, and 8 divided by 2 is 4. So we have 2 and 84. Then we're going to try 3. So the rule for 3 is that can I add the digits? If the sum of the digits is divisible by 3, 15 divided by 3 is 5, then so is the number. So this is going to be 3, and now I know it's divisible by 3, but I don't know what it is, so let's break it down. So this is going to be, what? 3 goes into 16 5 times. 5 times 3 is 15, gives me 18, and so that's going to be 56. By the way, when I see 3 divided by 168, what I actually really do in my mind is I break 168 to 150 plus 18, because I know 150 is divisible by 3 and 18 is divisible by 3, so I'm picking an easy number that's close to 168, and 150 is a pretty clear easy number. 15 divided by 3 is 5, so this will give me 50, and this will be 6, which is also 56, which I think is easier than this algorithm that we usually do for long division. Okay, so then we got 4. So we'll do 4. And so 168 divided by 4, well, we know 16 divided by 4 is 4, and 8 divided by 4 is 2. So notice, it's nasty, but it's not that nasty. You can do this in your head. 5 is not going to work. 6, now if 2 and 3 works, then 6 is going to work. So you can, again, once more, you can see the power of the divisibility rules. So many times does 6 go into 16? It's going to be 2 times 12, it's going to give me 48. 6 goes into 48 8 times, so this is 6 and 28. And we're going to have to keep going. So 7. Now, there is actually a rule for the divisibility of 7, but it's complicated, so we don't really discuss it. So I'm just going to have to brute force this. But it does work. Look, 7, 28, 4 times, so 7 and 24. Let's just keep going. 8, we know 8's going to work. 8 goes into 16 2 times. 8 goes into 1 once, so 8 and 21. And then so much that I'm off the page. Now, I know that for 9, let's look here. So for 9, where is it? We got 15 when we added up the digits, right? So for 9, it's not going to work because 9 doesn't go into 15. 10 doesn't work. 11's it's not going to work, and then we have 12. Now 6 and 2 work, so 12's probably going to work, but let's do it. So 12 into 168, that's 1, that's 12, that's 48, that's going to be 4, so 14, so 12 and 14. 13's not going to work, and we're at 14, so then we're right back. So it's a lot of work, but there you have it. Okay. I'm not going to list that here, but let's do the next one, 135. Okay. So for 135, let's see if I can squeeze it in here. So here's 135. What are the factors of 135? Well, obviously 1 and 135. It's not even, so 2 is not going to work. In other words, it doesn't end in 0, 2, 4, 6, or 8. 3, we can add the digits and see what happens. We get 4 plus 5, which is 9. 9 is divisible by 3, so that works. So we have to still do it, so 3 goes into 135 how many times? 4, 12, 1, 5, 5. By the way, later on in the course, we will formally go over how to do long division, so if you're getting a little jumbled up with this, we will go more in depth a little later. 4 is not going to work. 5 will work because it ends in a 5. So let's do 135 divided by 5. This is going to be 2, 10, 35. So this is 5 and 27. Again, with 135, what I would do actually is break 135 down to 100 plus 35. Because I know both of these are divisible by 5. This is going to be 20. This is 7, so it's 27. I think it's easier, but to each their own. 6 will not work because 2 doesn't work. For 6 to work, both 2 and 3 have to work. 7, I'm not sure. Let's just try it. 135 divided by 7. So 7 goes into 13 once. It's It's going to give me 6 left over. Now I'm going to get 65. Now we know that 9 times 7 is 63, so that's not going to work. Then 8 is not going to work. 9's going to work because when we added up, we got 9. So when I say when we added it up, I'm talking about the digits. So let's divide by 9. So the 9 goes into 13 once. 9. This is 45, so this is going to be 5. So it's 9 and 15. 10 obviously is not going to work because it doesn't end in a 0. 11 is not going to work. 12 is not going to work. 13, no. 14, no. 15. And there you have it. So, the bigger numbers, it's a little difficult. If you don't know, you kind of just have to brute force it and try. I will say this. This is something to look at when we're talking about prime factorization. And this is something that's not formally discussed in this section, but I think it's really, really useful. And that's, let's see if I can erase this. That's that, let's take 135. What I'm doing a lot of times, in all honesty, is, I know the question is not asking us to do prime factorization, but if you do break it down to the prime factors, right, you're going to get 3 times 3 times 3 times 5. And what I want you to realize here is that all of the various ways of combining 3 times 3 times 3 times 5 gives me all of these factorizations, right? So if I just do 3 times 3 times 3 times 5, I get 135, right? If I siphon it with 3, I could take 1 3, put it by itself, and everything else, I get 3 times 45. If I take it and I siphon it such that it's just 5, 3 times 3 is 9, 9 times 3 is 27, I get this version. And if I break it so that I'm, sorry about that, but if I break it so that I'm pairing the first 2 and the second 2, I get the last one. So prime factorization is very powerful because if you write the prime factorization and you just sort of divvy up all the different various combinations of it, you will get your list of all the various types of factors. So if you're not certain, one advice, write the prime factorization and use that to guide you. And that's actually what I was doing in my mind as I was working through. So when you're sitting, you hear me saying, hey, 12's not going to work. Well, I know 12's not going to work because none of the prime factors are 2, right? So keep that in mind as you're working through. A lot of these, this is kind of neat because a lot of the skills that we pick up are actually really useful for the other sections. And this is a common theme in math. Again, I'm not going to write 8 in. We have it down below. You can go back in the video if you want to copy it down, or hopefully you've written it down on your own piece of paper and you know what it is. Okay. Now, next bit is we're trying to figure out if it's the prime, composite, or neither. So we know the only one that's neither here is going to be most likely 1. 1's not on the list. Don't have to worry about it. We know if it's, I'm going to use C for composite. We know that this one, and this one automatically have to be C. And my question to you is why? So hopefully what you've quickly realized is that they're all even. And because they're all even, they have to be composite, right? The only even number that's not composite, the only prime that's even is 2, okay? Then we go to 47, and for 47, I'm not certain initially at looking at it. What I can do is use my divisibility rules to try to figure it out. So, for example, it's not even, so it's not, right? It's not going to be divisible by 2. It doesn't end in a 5, so it's not divisible by 5. 4 plus 7 is 11, which is not going to be divisible by 3, so the number is not divisible by 3, nor 9. So I've exhausted my divisibility rules. If I really want to check, I'll go through and do every single value, but I'm going to be a little lazy here and say, hey, look, 47's right there. So 47 is prime. So using your divisibility rules doesn't guarantee you that the number's not prime, but it does give you a higher chance of that being the case. And 31 is the same thing. If you run the divisibility rules right, it's not even. 3 plus 1 is 4, so 3 and 9 are out of the question. It doesn't end in a 5. You have a high chance of it saying that it is prime, and just to show you, 31's right here. Okay. Again, I want to encourage you to put your answer down and then check the list to see if it's prime, because on a test, you may see the number and you're not going to have the list with you, right? For number 13, it does fail the divisibility rule in terms of being prime. It's going to be composite, and hopefully you see why, because it ends in a 5. 57 is also composite, and hopefully you can tell me why. The easiest way to see it is it fails the rule for 3. 5 plus 7 is 12, so since 12 is divisible by 3, I guess I should say it passes the rule for 3, hence it's not prime. And then 13, we've seen 13 before, we know that it's prime. So once more, just to prove it to you, it's on the list, it's right there. Okay, so let's go on to the last bit, and actually, I'm at the 26-minute mark. I got about 4 minutes left, which is not enough time for me to go through and do all of this. So I'm going to go ahead and stop the video here. Next time, we're going to pick it up from prime factorization. Go ahead, if you haven't done it by already on your own, please try it on your own first. Math is not a spectator sport. You want to try it on your own first. Get comfortable with it as much as you can on your own, and then once you get stumped, then you can watch the video and see if your answers match up with mine or what you weren't seeing from before. So, with that being said, go ahead. I'll stop here, and I'll catch you all in the next video.